So factor each. One root has been given. Now the reason why one root has to be given is because you have a cubic and a cubic. Anything larger than a quadratic, you can't factor it. Normal means. The only strategy you have is grouping, right? And that's like, that rarely ever happens that you can group. That's like somebody genetically engineered a math problem for you to use grouping. It hardly ever works. So what happens then is that if we get this guy to drop a degree, we can factor using quadratic techniques like factoring AC method or quadratic formula. Now in this case, you are given a root of -2, which means that -2 will go into him evenly because he already is. One root has been given. So that means -2 is a 0. Therefore, -2, i.e. x plus 2, will go into x to the third plus 5x to the second plus 8x plus 4. It will go in there evenly. All right. So what we're going to do is we're going to figure out if I can get this guy to drop a degree, I will factor him and get the other factors. So already I should have an x plus 2. So for C and A are no good because I need an x plus 2 because I was just told that -2 is a factor. So let's factor this. Or let's divide. 1, -2, that's 3, -6, that's 2, -4, that's 0. It was supposed to, right? It was supposed to go in evenly. I'm expecting a 0. If a 0 doesn't happen, then -2 wouldn't have been an actual 0. Or a root. So now what's left is this. Now remember, if I had x to the third and I was dividing by x minus 2, that is an x, okay, by degree, I'm dropping this to an x squared. So this is a 1x squared plus 3x plus 2. All right, so far, I factored this much so far. Well, it turns out I can actually factor this guy. Well, I can get this guy to turn into two other parentheses. So what are those? Factors of 2 that add up to 3 is easy. It's 2 and 1. So this means that I have, don't worry about him, he's x plus 2, he's over there. This guy would be x plus 2 and x plus 1. Now don't flip their signs for the factoring. Don't do that. All right. So we do have technically this equals 0, so that's just kind of for show. It doesn't really matter. But we've got 2x plus 2, so we can further abbreviate this as I'm running out of room here. We'll go up here, x plus 2 squared times x plus 1. And you can see that right here. All right, now again, the equals 0 is just, it's actually not necessary, but that's the idea. Okay, so when you get, this means that there's a multiplicity of -2. The parentheses show up twice. So this means, again, that if we go back to 17 and 18, that means that there's a bounce that occurs with this particular polynomial. All right? So over here we have x to the third, blah, 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 equals 0, and -5 is a root. So we're going to throw in -5. We got 1, 12, 45, and 50. Now this has to be 0. What's of interest to me is what happened before 0. Okay? I know that's going to be 0 because I'm already told one root has been given. All right? So we drop the 1, -5, that's going to be 7. That's -35. That's going to be 10. -50, of course. It's supposed to equal 0. I wanted this stuff, okay? Because this stuff tells me that x plus 5 is here, okay? Remember, it's the opposite of what you see up here for the parenthetical display of the function, the factored form. And this is x squared plus 7x plus 10. Now this guy is factorable. Okay, now he's still there. X plus 5 is still there. But this guy is going to be factors of 10 that add up to 7, and that's 5 and 2. So it looks like we've got x plus 5 again and x plus 2. So this also has a multiplicity of 2. So it looks like x plus 5 squared times x plus 2 is right there. Okay? All right. Now this is going the other way. This is saying I have all the factors. I want to know what the standard form is. All right? Now this is of least degree, so it's totally not accounting for bounces or multiplicities unless they're explicitly stated. Okay, here this is stated, so I'll show you how to handle him in a second. But 2 is already there. This is a multiplicity of 2. Okay, those two are kind of connected together. But let's go ahead and see what we got here. If we have a polynomial function and your root was a 0, then we will just have an x there. If you have a root or 0 of 2, then we would have an x minus 2. And if we had a negative 1, then it would be an x plus 1. So all we have to do then is FOIL that out, and we're going to get this in standard form. Okay, one of these guys is going to hit the x-axis at these 3 points. So I'm going to go ahead and just FOIL out the first two, x squared minus 2x. Okay, and then I'm going to go ahead and distribute using just plain old using FOIL. All right, so x times x is x to the third. X plus x squared, this will become negative 2x squared and then minus 2x. So then finally, those two will combine to get an x to the third minus 1x squared minus 2x, and that is C. Okay? Alright, so now this is a little bit more work because with a multiplicity of 2, that's 1, 2, 3, 4 degrees. Okay, over here it's just 1, 2, 3 degrees. So I'm looking at cubics. This is 1, 2, a multiplicity of 2, because there's a bounce here. So 1, 2, 3, 4. So 1, that would be x minus 1 squared times x minus 2 times x plus 3. Now I'm going to multiply that all out. Here's just got to be careful. So x, I might need more room here. I'm going to take care of this x minus 1 squared up here. Alright, so that's that guy. And then I'm going to multiply these two guys together, and I'm going to get x minus 2x plus 3. That would be x squared minus 2x plus 3x is 6. Alright, now I'm just saving video time. I mean, you could pause it. Here, pause it. Right now, pause it and multiply it out. Ready? 1, 2, 3, pause. Okay, welcome back. Now, you've multiplied that out, and this is what you get. So now I need to multiply these two times these two. So I'm going to have to, if you want to be careful, or if you just think you're super cool, and you do this without the box method, congratulations. But for the sake of this video, I'm going to do the box method. So I get x to the fourth. Okay, so remember I'm multiplying two trinomials here. Alright, these two and these two still have to be multiplied together. So I get x to the fourth, and then I get negative 6. Now here's why, the reason why I'm doing a head and a tail here is because that might actually help me get rid of some of them. I can only get rid of d, okay? But now I'm going to go ahead and do this diagonal. This is x to the third. This would be negative 2x to the third. That would give me negative 1x to the third, and it looks like every single one of them is negative 1x to the third, so I'll move on. The next diagonal would give me x to the second. This would be negative 2x squared, and that would be negative 6x squared. Alright, I'm just multiplying this times this, this times this, and this times this. This diagonal, notice that they're all like terms. If I add them together, that's negative 8 plus positive 1 is negative 7. Looks like they're all negative 7. So now we go to the final one. We have x. We have positive 12x. That would be a 13x. Okay, so 13x looks like this has 13x, but we already crossed him out. So it looks like this is the only one with 13x. This is our guy. Okay, so the final answer is E. Okay, so I kind of took it easy on this stuff. I could have put complex conjugates. I could have put irrational conjugates for you to do, but I did not do that. I don't know. I was possessed all of a sudden with a kind heart, since the test is going to be so large. So let's end it. Good luck, and make a great note card. And 10:30, not too late. It's not like it's 12:30 like yesterday. It was for Algebra 2. All right, yeah, have a good night.